Hi, third grade. We're gonna go through a lot of pages because it's just multiplication, which is a big part of third grade. So this one is multiplying by 7, and the answers are mixed at the bottom of the page. You cross out the answers as you complete the problems. So something to think about, those answers at the bottom, you actually could take those and write those in order. So I'm just going to write the multiples. I'd like you to say those with 7 with me. Okay, let's just practice those. So I have 7, and what's the next one? 14. You try to guess it before I write it. 21. Try to guess it. 28. 35. So I'm up to 7 times 5. 7 times 6. We just did that one. We did 6 times 7 in the other page. 7 times 7. This is the 7th multiple, or skip counting. 7. Same with me. 14, 21, 28, 35, 42, 49. Okay, the next one. 56. Try to guess the next one before I write it. This is going to be 9 times 7, 63. And 10 times 7, you know that one, 70. Good. So these can help you, and you can do this on any test, and it's just a great reference. Okay, so I'm just going to go through and do these. You cross them off at the bottom. Okay, so 3 times 7, my third multiple, 21. 6 times 7. Ooh, that was that one that we talked about. It's a memory fact. Tricky one, tricky one. 42. 8 times 7, you could look it up. 1, 2, 3, 4, 5, 6, 7, 8. 56. 2 times 7, that's probably one that you're familiar with. 14. 9 times 7. Okay, so that's like the last one. 70 minus 7. Okay, 63. Just one you have to remember. 1 times 7. Okay, there's an easy one. We talked about 0 before. That's 7 rows with 0 in each row. So got to be 0. 10 times 7, we talked about shifting. And we're going to come back to more of that at some point. Shifting on a place value chart. Shifting on a place value. That's 70. 4 times 7. 1, 2, 3, 4th multiple. 28. 5 times 7. 35. You probably know that one. Now they're changing the order. There's 3 times 7. That's that commutative property. And 0. Okay, let's check out the next page. There we go. 7 times 2. I think they're just changing the order on that one again. 7 times 10. 70. Shifting in place value. 7 times 4. Now I don't have my multiples written here anymore, but you could write them and look at your page for that. 28. And again, this is the same factors. They're changing the factors. Remember, they're changing the factors, but the product is the same. 1 times 7, the factors 1 and 7, the product is 7. And 7 times 1, the product is also 7. Because this means one row with 7 in each row. 1, 2, 3, 4, 5, 6, 7. There's one row with 7 in each row. That's 7. Here's 7 rows with in one column. 7 rows, just one column. So we'll do our 7 rows. 1, 2, 3, 4, 5, 6, 7. So there's 7 rows, just one in each row, or we can say there's one column. Okay, we'll fill in the rest of these. 35. And this one is the square. That's the one we talked about. It makes a perfect square because you have 7 going down and 7 going across. So 7 rows with 7 in each row. 49. Okay, 49. And again, if you make that array, 1, 2, 3, 4, 5, 6, 7. If you had 7 of those, 2, 3, 4, 5, 6, 7. You could go through and just make an array for some of these larger ones. It's easier to do the multiples. But let's just do an array. It's just to look at our array pattern again, because array is just multiplication. Woo, it's so big it's getting hard to do. Maybe this wasn't such a good idea. Yikes, because it's really hard to write on this screen, because I'm not writing, the screen is not just flat in front of me, so I I was just going to show you real fast. You could literally go and say, okay, I've got that, and that is 7. I could do the next row, another 7, 14, and you could count your way on down. 21. Let's count. 21. What would be next? 28. What would be next? 30. What? 35. Good. 7 more. See if you can guess it before I write it. 42. And 7 times 7. 49. Whoops, that doesn't look like a 9. 49. There you go. Okay, let's go to the next page. Okay, so now we're multiplying with 8. Multiplying with 8, just a lot of multiplication. So let's write those multiples down here so that you have them and you can refer to those on your paper. Put those. First one, 8 times 1 is 8. 8 times 2, 16. 8 more, 8 times 3, see if you can guess it. 24. 8 times 4, 32. And 8 more. This is 1, 2, 3, 4. This is the fifth multiple. 8 times 5, 40. 8 times 6. That's a good way to remember. 8 times 6 is just go to 8 times 5 is 40 and add 8. 8 times 6, 48. 8 times 7, 56. And 8 times 8, that's that square we were talking about, where it's the array that has the same number of rows and same number of columns. 8 times 8, 64. 8 times 9, 70 what? See if you can guess it. 72. And 8 times 10 is 80. Okay, so then you can go through. This is a fact just for the 2's. So for example, so you probably know this one already, 16. 6 times 8, there's the one we just talked about. You could think of 5 times 8, which is 40, and then add 6, one more group of 8. So 5 groups of 8, or 5 copies of 8, and then one more copy, 6 copies, 48. Okay, 7 times 8. And if you want to just pause the video, fill all these in, because I'm going to go through these, because you should just probably have all this work done and just checking it with me. Okay, you can count by 8s or by 3s, either one for this one. You could do 3, 6, 9, 12. What comes after that? 5, 15, 18, 21, 24. Okay, so if you could do 8 copies of 3, count by 3s or count by 8s, but 24. All right, here we go. See if you can just going to check these. We've talked about this one already. We talked about 0 already. 10 times 8, we talked about this shifting concept. I'm going to keep writing that down. I want you to be learning that on a place value chart. Times 10. Next year, that's a big one. Big one. 80 and 4 times 8. 4 times 8, 32. Again, you can write those multiples or skip count by those. Okay, let's go next page. Okay, so then you're just finishing up. And again, I don't have the multiples written, but you're just crossing these off as you go. 5 times 8, 40. And remember, we talked about how we could use that for 6 times 8. Okay, because that would just be one more group of 8. And here we are just changing the order. Commutative property, 24, 0. Changing the order. Remember, these things, what are these things called again? Starts with an F. What are those called? 1, 2, 3, say it. Factors. Change the order of the factors. And then what's this thing called here? The answer in a multiplication. That is the product. Good job. Okay. 80, 32. We did this one earlier. Just changing the order. 56. Changing the order here again, look. 40. And there's the square. Remember, there's 8 rows and 8 in each row, or 8 rows and 8 columns. 8 rows, 8 columns. Makes a perfect square. 64. Nice, nice, nice. Let's go check out our... Okay. This is multiplying by 9. All right, nines are super cool because they have an awesome pattern. And so I think what I'll do with the nines, let me make my screen a little bit bigger. Okay, so you know, math it's all about numbers. It's all about patterns. Okay, there's a lot of patterning in math, and patterning is a powerful concept. If you understand the patterns, we were just doing patterns by skip counting. Those are patterns. Okay. Well, the pattern of 9 has some interesting properties as well. So if we skip count and we do this vertically, we'd have 9, 18, 27. What would be next? What's next? 9 times 4, 30, what? 6. So right away you can see, and I know you as a review, you've talked about this pattern. Look at the ones place. What's happening with the ones? They are decreasing, aren't they? Interesting, right? What about the tens place? This number, in fact, has 0 tens. I could actually put a 0 right there, but it's odd. We don't normally do that. We don't. If there's no tens, we just don't record tens. If we just have a ones digit. So the tens place starts with 0 tens, then 1 10, 2 10, 3 10. So what do you think the next? What's the ones going to be right here? 9, 8, 7, 6, 5. What's the tens going to be? 1, 2, 3, 4. Pretty cool, huh? So you can easily write this. You don't even have to count by 9. You just, oh, there's a pattern there. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And this one starts with 0 tens and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And it works pretty well right up to about that point, and then the pattern is going to start over. Okay, the pattern starts over. So right about up to there, because that is 10. This is 9 times 1. There's 9 times 2. Okay, and this would be 9 times 10. So and this is as far as you need to go actually in 3rd grade. So that's an easy one that you can write. All right, here we go. 1 copy of 9. 1 9 is 9. 6 times 9. 6 times 9. Okay, now another pattern is, let's look at 6 times 9. So 9, I'll say 9 times 6. Okay, what do you notice about these digits? In each case, in the product, what's the sum of 9 and no tens? 9. This is 1 10 and 8 ones. Just looking at if I sum the two digits, it is 9. Here's 2 and 7. Sum those two digits. 9. 3 plus 6. 9. 4 plus 5. 9. 5 plus 4. 9. 6 plus 3. That's a pattern. All the digits are going to sum to 9. Okay? Now, look at the tens place. Okay? Really cool here. I'll put 9 times 4. 9 times 5. Watch this. Very, very cool. 9 times 2. Okay, for example, 2, and then look at the digit in the tens place. 2 minus 1 is 1. 9 times 3. 3 minus 1 is 2. 9 times 4. Look at the pattern. 4 minus 1 is 3. 9 times 5. 5 minus 1 is 4. And now 9 times 6. 6 minus 1 is 5. 9 times 6. 6 minus 1 is 5. These two have to equal 9. 5 plus what is 9? So just a fun pattern. You know, ideally you want to just learn these, but it's so fun to see the patterns in math because they can come in handy when you're doing different problems. So eventually you're just going to commit these to memory. But in the meantime, it's a lot of fun to look at these patterns. So okay, 9 times 6, 7. 7 minus 1 is 6. 6 plus what is 9? 1, 2, 3. 6 plus 3 is 9. Look at that. Okay, and over here, this may be just a fact you already know. 2 9s are 18. 2 copies of 9. But this is a tricky one. 9 times 8. Ooh, it's a memory one. That's hard. But wait a minute. We can do something. Not just with using our fingers, but let's really use our mental math. 8 minus 1, 7. 7 plus what is 9? 2. By the way, this is why this works on your fingers, okay? This is what's actually going on here. 9 times 3, well, that's a 3's fact. You probably already know that because you know your 3's. That's a 0. This is 90, of course. This might be one that you may or may not know, okay? But 4 minus 1 is 3. 3 plus what is 9? 6. Okay, cool beans, cool beans. Okay, so let's finish these up. 5 times 9, you probably know this is a 5 fact, so that's not a big deal. You probably know that one. 9 times 3, that's a 3 fact, so you just think of this as 3 times 9. That's something you already know. 9 times 8, that's a tricky one, but wait a minute. Let's use our trick. 8 minus 1, 7. 7 plus what is 9? Remember, in the 9s, those two digits, 7 plus 2, equals 9. 9 times 3, look at the answer, 27. 2 plus 7 equals 9. 9 times 5, okay, look at the two digits in the product. 4 plus 5 equals 9. You got it, you got it. There's a 2's fact, you know that one. Times 10, you know, you're just shifting. That means you're putting a 0 there. This one you might say, tricky one. 4 minus 1 is? Now remember, this only works for the 9s. This only works for the 9s. 3 plus what is 9? 6. Nailed it. Nailed it. We nailed it. 9 times 7. Here's a good one. 7 minus 1, 6. 6 plus what is 9? 3. You got it. You got it. 9 times 5. 5 fact. We know it. We know it. We got that one. Ooh, here's the square we're talking about. This is 9 rows and 9 columns. Ladies and gentlemen, 9 row, 9 columns. Whoops. Okay, but wait a minute. 9 times 9. What's 9 minus 1 is 8. 8 plus 1 is 9. I mean, whoops, I gave it to you. 8 plus what is 9? And the answer is 1. Woohoo! All right, good job, good job. Write the missing numbers in the boxes to make each multiplication problem come true. Okay, so they are, here we're looking at changing the order, using order to multiply, okay? Remember, we can change, remember, we can change the order of, and I'll come down here, the factors, and the product. I'll have to come down this way. It's going to be coming off a cliff, okay? I'm going to write it going off a cliff. Whoa. And the product stays the same. Whoops. Okay, so we just did something. Hold on, hold on. So I got too close to the edge of something. Something happened here. We better watch that one. The product stays the same. Okay, here we go. Here we go. 5 times 6. Okay, that's a 5 fact. That's going to be 30. Pull the switcheroo. Does it matter? Not at all. It's going to be 30. What's the name of that property? What's the name of that property? Starts with a C, by the way. Give me a C. 1, 2, 3. Say it. 1, 2, 3. Commutative property. Commutative property. Okay. Sounds like something in Monopoly, right? The commutative property. 2 times 6 is 1, 2, 3, 12. So guess what? 6 times 2 is, you got it, 12. 4 times 5 is 20. So 5 times 4 is 20. 3 times 8 is 24. Now, I should have told you, stop the video, make sure you do these before. Don't just do them with me. These are just facts, so you got to practice them. But the main thing is if we change that order, change the order, voila, 24. 4 times 7 is 28. Change the order, and what do you have? 28. 5 times 9, 5 fact. And you know what's the nice thing about changing the order is, look, sometimes if you look at 9 times 5, you might think, oh, I got to count my 9s, but I'm not really sure about my 9s. Well, let's just change it to 5 times 9, because you know your 5s. There you go. Make the math work for you, ladies and gentlemen. Okay, hold on. Okay, here we go, here we go. Again, here's 9 times 2. Ooh, now we're getting tricky here. Now we're getting tricky. Let's look at this. 2 times what is 18? So you just got to know those facts. 9 times, in fact, remember, pause the video, you fill these in. Oops, I gotta fix myself. I'm sliding off of this. Hold on. I'm gonna take myself for a little quick tour, okay? Whoa! Whoa! There I go. Okay, so fill these in. 9 times 2, but you can think of it as 2 times 9. Think of it as a 2 fact. That's 18. So what's going to come in here? We can just change that order. 2 times 9. Okay, count by 5s to 15. 5, 10, 15. That's going to be 3 of those. 3 5s. We can change the order. 5 times 3 is 5 copies of 3. So either way, I can go 3 copies of 5, which is counting by 5s, or I can do 5 3s. 3, 6, 9, 12. What's next? 15. There's my 5. 1, 2, 3, 4, 5. Okay. 8 times 7, 56. What times 7? 8. Oh, I said that wrong. 7 times 8 is 56. What times 10 is 70? Okay. 10 times what is 70? All right. What's going to go here? 2. So what's going to go here? 2. You got it. 3 times what is 12? Now this is probably one you're very familiar with. 3 times 4. So what goes here? 1, 2, 3. Hope you said 4. So look at 6 times 5 and 5 times 6. How does the order of the factors change the product? 6 times 5 and 5. How does the order? Oh, how does the order of the factors change the product? Well, the order of the factors does not. Okay, so I'm not sure why they worded it that way, but how does it affect the product is what they should say. Let's change that to have an effect on the product. Okay, if I have 6 rows and 5 in each row, 5 rows and 6 in each row, we know changing the factors, the product is not changed. Okay? So how does it change? You might, and you want to write in a complete sentence, you can say, I would say something like, say changing, so that you're practicing the terminology. Changing the order of the factors, and then I'm going to make a big blank. What would you put in that blank? Changing the order of the factors. What would you put there? What would you put there? Does it change the product? Does it not change the product? Let's read it together. Changing, 1, 2, 3. Changing the order of the factors does not change. Does not change. And I'm going to have to fit this in, so I'll make a little caret there. You know how to do that? Does not change the product. Okay, let's look. We're almost done. Draw 2 arrays to show 4 times 7 and 7 times 4. So let's draw an array. Array just means using rows and columns to show something. Okay, so here we have 2 arrays. We have 4 rows. So let's make 4 rows. 1, 2, 3, 4. 7 columns. So 1, 2, 3, 4, 5, 6, 7. 1, I'm starting with this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so what this does show is shows 4, and this is 7. This means 4 copies of 7. See, there's a copy of 7 right there. So that is, if I was going to count what's in there, that'd be 7. Counting by 7s this way, okay? 14. What's next? 1, 2, 3. Guess it. 21. And one more group of 7. 28. Okay, now let's look at the other one. 7 rows. So this time it's 1, 2, 3, 4, 5, 6, 7 rows, 4 columns. My first column, 2, 3, 4. 2, 3, 4. 2, 3, 4. 2, 3, 4. 2, 3, 4. 2, 3, So this time, look, I am counting by 4s. So here's my 7 rows, 4 in each. 7 times 4. So now I've got a group of 4. That's 4. One more, another group. 8 altogether. How many now? 4, 8, how many? 12. Okay, by the time I finish circling this, you guess what's the next one going to be? 16. Guess the next one. 4 more. 20. Guess the next one. I'm going to get a little faster now. Say it. 24. And the last one, you got to say it really fast. 28. So there's our proof. There's our 2 arrays. And you survived a lot of pages. That was 10 to 13. Congratulations. If you've already done the work, just listen to the video, and you can just, and it'll help you just to remember a little bit about what multiplication is. Remember, you can stop the video and go forwards and backwards and all that. Or you can get popcorn and invite the whole family to watch, okay? Probably aren't going to do that. Okay, thank you very much, and we'll look forward to seeing you on our next video. Thank you.